As a recap, in the previous video, we set up our levels, grids, and columns. We added our beams, and then we added a beam system. Now we are going to do our second level floor construction, the foundation, and some cross bracing. And this will complete the modeling of the structure. And then in the next video, we will go into connections. So let's get started. This structure that we are creating is going to be a warehouse. So we need it to be tall, that way they can put lots of shelving in there or whatever they need to get in there to be able to house whatever may be housed in this building. And therefore that's why we have 3 levels, so we have some high bay areas. This area here at the back, we're going to actually add a floor in there, so this area could be something else. It could be used as offices or maybe some isolated areas of storage that aren't housing tall objects. So we're going to create a floor in this area back here. So let's get started on adding the second level. Let's go to our level 2 plan, and the first thing I want to do is set my detail level to fine, and I'm going to zoom in here on this portion of my building. And now I'm going to go to my structure tab and I want to select beam, and I want to go back to the one I used originally, which was the 14 by 30. And then I'm just basically going to go from midpoint to midpoint. And because I have chain checked at the top of my control panels, I can just continue on around. So I can just scroll down and go to here. And then I'm going to go ahead and come across to here, and then I'm going to go back up to here. I also want to add a beam in the middle, so I'm going to stop my chain, and again I'm going to go to the midpoint and I'm going to come back down to here. Again, if I go look at this in my 3D view, you can see I have these set up at level 2, which is what I want. So I'm going to go back to my plan. And the next thing I want to do is I want to add my beam system. So I'm going to go back to my structure tab and I'm going to go to beam system. And again, I want it to be a fixed distance, and I'm going to leave it at 5 feet. And I want to make sure that I have that smaller beam selected, which I do, which is my W4 by 13. This time we're going to use the automatic beam tool, and you'll notice if I get close to one of these, you'll see the direction of those beams. I'm going to place mine in this direction, and then I'm going to do the same thing here. Again, once I have these placed, I always want to go to my 3D view to make sure it looks like I want it to look. You'll see I have my main beams, and then I have my secondary beams, which are smaller. And again, these could be joists instead of beams, but for simplicity's sake, we're staying with the same types of members. Now, because I have a beam running across here, I need to have a column underneath that beam, and it only needs to be at the first to the second level. So I'm going to go to my level 1 plan. I'm going to select this column, and if I right click on it and I do create similar, it will give me that same column, so I don't have to go back and look to see what that is. I want to keep it on height, and I want to set it just to level 2. I don't want this to go up to level 3. So if I come over here to my grid and I hit my space bar twice, I can place that column there, and then I also want to place one here. Once I get those placed, I want to go back to my 3D view, and you can see now I have a column underneath that beam. And right now they're kind of all intersecting together, but we will clean that up when we do our connections. Now we are ready to move on to our foundations. So I'm going to go back to my level 1 plan, and I need to add some footings underneath each of these columns. So again, if I go to my structure tab and I go to isolated, you'll see it only has 2 loaded in there. So I'm going to go with the smaller of the 2. And I have the choice of doing at grids or at columns. So I'm going to go ahead and do at columns. So if I click on that and then I select all of my columns, you'll see they came in the correct direction. We want them to be in the long direction, the direction that our column is going. But if I wanted to change them to go the other direction, all I have to do is hit my space bar and it will do that. So now all I got to do is click on my check mark. I'm going to go to my 3D view and you'll see we have footings under each of our columns. These are isolated footings. Next, we are going to add some cross bracing to our building. I know we have seen some cross bracing when we've gone to the job site. Cross bracing is basically used to keep buildings stable when the wind blows and during seismic events such as an earthquake. We are in a small earthquake zone. In case you weren't aware, the New Madrid fault line extends 120 miles in southeastern Missouri, or what's known as the Boot Heel, and into northeastern Arkansas. According to Missouri State Emergency Management Agency, it's an extremely active seismic zone. While it is more frequent to have the potential for an earthquake in southeast Missouri, there are also other faults located in Missouri and surrounding states. Some scientists believe there is about a 10% chance of a magnitude 7 to 8 earthquake in the New Madrid seismic zone in a 50-year time interval. So we do design for earthquake in Missouri and in our area. So we do have cross bracing for that. We also have cross bracing due to wind. It also limits the building's lateral movement, including the likelihood of damage to the structure's components and cladding. It's typically constructed from steel rods, angles, or tubes. Cross bracing includes diagonal members in a vertical plane placed in the shape of an X. Cross bracing is typically located in line with building columns and may be concealed within the non-structural wall systems. So it is important that we include cross bracing, and again, an engineer will tell you what that cross bracing needs to be. So next we are going to add cross bracing to our structure. I am going to add cross bracing between these two columns and these two columns. I want to use an angle bracing. Keep in mind you can use all kinds of structural pieces to do that. It can be tubing, it can be round tubing, rectangular tubing. There's lots of different options, and again, the engineer will tell you what this needs to be. So I'm going to go back to my structure tab, and you'll see right here I have brace. So if I click on that, you'll see I have some different things over here. What I want to use, I said I wanted to use an angle, is not listed in here. So I need to go to load family. So I'm going to go back to my structure, and I'm going to go to beam, and I'm going to go to load family. So if I scroll down to my structural framing and I go to steel, if I scroll on down here, you'll see I have L angle, which is what I want. So I'm going to click on that and I'm going to say open, and it's going to give me some different sizes. Before we select one, I want you to understand what angles are. A steel angle, also named angle iron or steel angle bar, is basically manufactured by hot rolled carbon steel or high strength low alloy steel. It has an L cross shaped section with two legs, and those legs can be equal or unequal, and the angle would be 90 degrees. Structural steel angles have lots of dimensions to comply with whatever need we need them to be for. The smallest one I have in here is an L8 by 8 by 1 1/8, or I have an L8 by 8 by 1. I have an L8 by 8 by 7/8. These are the lengths of the legs, meaning these are equal legs on my angle. This is the thickness of the material. I'm just going to pick this first one here on top, and I'm going to say okay. So now if I go back to my structure tab and I go back to brace, you see I now have this in my project browser. To place a brace, I have found the best option is to go to an elevation. I could do it in this by putting a check mark in my 3D snapping, and then it would pick to the middle point there, but it's a little bit easier to do it in an elevation. So I'm going to open up my east elevation, which will give me the side view of where I want to place this cross bracing. Once in my elevation view, if I go back to my brace command, you see it gives me the work plane. If you recall, if we looked at our plan, that this bracing is on column line C. So I can just go to name and I can pick grid C. So I'm going to say okay. And now I'm going to draw. I don't want to start clear down here at the bottom. I could, but I'm going to come up about a foot. And then I'm going to come over here and I'm going to come down about the same distance. It doesn't have to be exact. And you see now I have my angle in there. I need the same thing happening here, so to make sure I get it exactly the same, I'm going to use my mirror command. I can't use my mirror pick axis because I don't have a center axis line in here, so I'm going to have to use my mirror draw axis. So if I do that and I pick the midpoint of one of these beams and I just come straight down, now I have the exact same situation. So as usual, I want to go into my 3D view, and you can see that I can see my angles now. We're still not completely done because we want them to back up to each other. It makes a better connection. If I go to shaded and rotate around, and you can see that I have a flat surface here and a flat surface here, and then I have a flat surface here and a flat surface here. So I need a flat surface against each other, and I don't currently have that. If I select this one, you'll see right here I have cross-section rotation. So if I take that and I put in 180 degrees and I hit apply, you'll see now I have a flat surface here and a flat surface here, but they're still crossing each other. So if I switch to my top view, you can kind of see there's a light blue line in here. That light blue line is the center justification. So if I take this one, and you'll see over here I can do some different things with my justification. So if I select my Y justification and I click on it, you see I have origin, left, center, right. I'm going to start by picking left and hit apply. So I need to go back again to my 3D view and see how they are lining up. Now I need to go back to my top view. So now I want to do the same with the other one, and with my Y justification I'm going to try right, and now they are beside each other. Mine is actually backwards. I need these angle pieces to be next to each other, so I'm going to change this one to right, and I'm going to change this one to left. And now I have my two angle legs against each other. If I go back to my 3D view, it should look correct. With having the flat edges against each other, we can just run a bolt through here to connect these. And again, just to make sure, I'm going to go back to my east elevation and I'm going to cut a section through here, and I'm going to look, and you can see if I change this to fine that I have my legs against each other like I wanted, so we could place a bolt where they cross exactly in the middle where that happens. So that works well. So we're in good shape. So I need to do the same thing on this side. So I'm going to grab my two members and I'm going to use my mirror command. So to do that, I'm going to go back to my level 1 plan, and I should have these selected, but say I lose my selection, if I right click, I can do select previous and it will pick those same ones. And I'm just going to do mirror and I'm going to pick my center grid, and now I have that. So if I go back to my 3D view and I look, everything looks good. Again, I'm going to go back because I'm always paranoid, and I want to make sure that I have the same situation. If I set this to fine, again, I have the same situation. It's opposite of that one, which is what I want. I want these on the outside and these on the inside. That's why I did a mirror. If I had just copied, they would have been backwards from each other. So now we are ready to move on to learning about connections. We are first going to learn about a column rafter connection. Then we're going to learn about choosing the right connection. We're going to learn about bolts. We're going to learn how to do an apex connection, creating custom connections, custom anchor connections, copying connections, creating a useful shortcut, cope skewed modifier, parametric cope, parametric cuts, contour cut, and still concrete beam connection, and transferring connections. Sounds like a lot, and it is, but you're going to have a really good understanding of connections whenever we complete these. So that's what we'll be doing in the next video.